In section 8 of chapter 2, we're going to be graphing square root functions, this time with multiple transformations. I'm just going to hop straight into the two problems, because at this point in time, you should be able to generate, at least from a descriptive standpoint, how to graph this. For the first one, I have y equals 3 times the square root of the quantity x plus 5 quantity minus 2. That plus 5 underneath the square root, you can kind of think about that as in parentheses because we're square rooting that entire quantity. Because it's next to the x, the plus 5 is going to dictate x-like movement. That's movement left and right. We do the opposite of the plus 5, so that means left 5. Then the negative 2 on the outside, that's going to dictate movement up or down. It's going to do exactly what we think. Negative 2 means we're going to go down 2. Then we've got that 3 way out in front. That 3 is going to take all of our heights, all of our y values, and it's going to stretch them. So we say we are stretching this thing, stretched, vertically by a factor of 3. So this is going to be 3 times taller than the mother function. All right, so let's do this. We're going to go left 5, down 2. 1, 2, 3, 4, 5, 2. Here is my starting point. Then I'm going to stretch this thing vertically by 3. Normally, we'd go right 1 up the square root of 1, which is 1. But I got to take that vertical component, not the horizontal, just the vertical, and I'm going to have to triple it. So instead of right 1 up 1, I'm going to go up 1, 2, 3. The next number we'd like to use is 4. So starting at the center, right 1, 2, 3, 4. We'd normally take the square root of that. We'd go up 2. But we got to triple that and go up 6 instead. 4, 5, 6, which is right here. And then last but not least, the next number we'd like is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Normally we'd go up 3, but I got to triple that and go up 9. 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The next dot, which I would have to generate by going right 16, will not fit. I don't have enough room, so this is my graph. Now, I'm not going to require that you do this, but I do want to take special note of the domain and range of this thing. The domain is where this graph exists in the x direction. The smallest value that this gets left and right is it exists all the way to right here. It exists all the way to negative 5, but it keeps going forever to the right, so the domain would be negative 5 to infinity. The range, well, the lowest this thing gets is negative 2, and it keeps going up forever. Yeah, it goes up slowly and slower, but technically, if I let it run forever, it will go up to infinity. So the range would be negative 2 to infinity. Problem number 2. The minus 1 is going to make me go right 1. The plus 4 is making me going to go up 4. The 1/2 is going to make me compressed, because it's smaller than 1. Vertically, because I haven't shown you how to do horizontal yet, by 1/2. And then lastly, that negative is going to flip this thing vertically. Flipped vertically. All right, so let's do this. Right 1, up 4. Right 1, up 1, 2, 3, 4. Normally we go right 1, up 1, but I'm going to take that and cut it in half, and I'm going to go down instead. So it's right 1, down to half. Next we'd go right 4 and up 1 typically, but I got to cut that, right 4 up 2. Got to cut that 2 in half to a 1, and I'm going to go down instead. So right 1, 2, 3, 4, down 1. Then we go right 9 and up, the square root of 9 is 3. Cut that in half to 1.5, make it go down instead. Right here. Now this one, the domain and range is a little bit different. The domain, the smallest it gets is right here. It doesn't go any further to the left, so it's from 1 to infinity. But the range, this function keeps going down. So in fact, the lowest it goes is negative infinity. This one actually has a ceiling. It has a top that it cannot go above. So the range for this blue graph would actually be from negative infinity all the way to positive 4, up 4. And this is how you graph square root functions involving multiple transformations.